Hey, good morning. How are you
Good
doing?
morning. Any question?
Yeah, I'm running into some issues on project two. I guess I'm just kind of confused on what the purpose of like something like clear and is empty and all that's supposed to be for.
Mm, Project two's goal is very easy. Okay, so basically you are going to build a try. Okay, so try
Right.
you're going to build try. So try is similar to hash map. Okay,
Okay.
so basically it's building dictionary, right? Building dictionary. So what we want to do is that you say you have some word, say A, B, okay, A, B, C, okay, and then you have X, Y, Z, for example, like this. So if you have this whole thing that's already in the dictionary, you will build a tree of A, right? And then A, B, right? And then you have A, B, C, right? Okay. So here you will build a tree like this. You will build a tree let's restart, okay? Let's restart. So your root has no information. Root just root. Okay. And then under that, you would have one A, right? After the A, you don't have AA, but you do have AB, right? So AA's part is null, and then you have AB, okay? And BA's null, so BB null, you have BC, right? So
Right.
something like that. And then you B first later B no until your X, and then after X, no, until Y, right? And then after Y, no, until your G. Yeah.
Yep.
So that's your tree, right? That's your tree. So when people ask you whether you have XYZ, you will check. Come here, right? Okay, yes, X. If no X, then that's you return false already. Okay. So you're building such a try to help you to check for work like a hash map, but it actually searching time is in the length of the data instead of searching the whole dictionary, right?
Okay.
Okay, that's a goal. Then what's your question?
I'm confused on like this clear section because I understand like add and I understand get, but I don't understand what clear would do.
Clear. Okay, let me put in up the homework. Okay, a moment. Clear is a function, right? Clear is a function.
Hmm.
So clear is clear the whole tree. So you just probably keep the root node should be enough. So clear is the probably the easiest one to implement. Okay, clear means that you have a try, right?
Hmm.
So you have a try. You already put in. Okay, so here let's assume that you have the first word is time. Okay, second word is actually t. Okay, so you build something like okay root nothing and then nothing until t, right? And then nothing until I, right? Then you build this. Okay, next one you add the T in. So T is actually, okay, I'm sorry. Here you have TIME, for example. Okay, after that you actually build a TE and A. Okay. And
Hmm.
clear means that you don't like this. You clear the whole dictionary. Just go back to root.
Okay.
That's what clear is.
Okay.
Remember that you have Java array list, right?
Hmm.
Java array list, say you have the array list of integer, right? And then a list equals new array list, right? Something like that. And then you say a list that add, you add something, right? So you say add a and then add b and then ac. So you create a after b after c, right? So you create such a array list, and then you say clear everything. So you go back to uh, empty array list.
Okay.
That's what clear is. Clear is to clear the whole data structure.
Okay.
Go back to the root node. That's it. That's very simple definition.
Gotcha. Okay.
Yeah, does that make sense?
Yes, that makes perfect sense.
Yeah, and then any other question? So
And-
here, like size, you need to return how many word been in the dictionary, right? It's MTC if the whole try is empty. Add, you can add a word into it, right? Get, you can get the word whether it's existing or not existing, something like that, right?
Mhm.
Okay, so and then you can use this as a just like a hash map, something like that. Yeah.
Okay.
Or hash
And then-
set. Yeah.
And then you want us to print every single word out in one succession?
Every single word out, so server print out all the word in the article in the right number of the occurrence. So you won't okay. So here that okay. Here what happens is that if you say you have a time, right? Time,
Mhm.
right? So time. So this one you may at the E you may under it you may recall how many times this one happens. Say 10 times. You the whole article have 10 times. So you want to you should have a function that you can print and then print the whole dictionary. How many times it will actually get. Is that okay?
Yep.
How many the whole dictionary each word? How many times it? How many times each word has? So you should be able to read in the whole article and then analyze how many times each word actually has. How many times each word occur? Okay,
Okay.
so here let's see. Okay, let me bring up my. This one is my try. So all the project actually, I did write it before myself. Okay, all the project, what I put into the project or assignment, I all wrote it before. So I changed it directly here. Okay, so the program is called try. Okay, it's called try. So here let's run this one. Python. Okay, TIRE.py. Okay, so basically this one, what I expect to have is like this.
Okay.
So let me show you. Okay, I cannot show you the code, right?
Right.
But I do show you the functionality is that here I have this one declaration of independence. I read this file in, right? So you can actually just keep the lowercase. So IN, okay, lowercase, Congress, lowercase, okay, and then July 4th. So that's you can ignore the punctuation mark. So replace all the punctuation mark as space. That's okay. Numbers as a space. That's also okay. I'm okay. I don't care. You do not need to put 1776 as a word. It's okay. All of these you can actually make them just a space. Use space to replace them, and then convert every word to lowercase. And S say you may have nature as a nature. Treat it as two words. That's actually okay. We are not as strict. Okay, we don't need you to consider those plural or singular cases. We don't need that. But anyway, you need to print out something that is A occurred in the article 16 times, did actually one time. Okay, so how to do this? Say you start with a try of empty, right? Okay, now in the article C1A, so you say, okay, there's a way, and I put one time for it. Okay, next time I try to add A again. It already in there, so I increase the number to 2. Next time I have another A, I increase it to 3. Okay, now I have abolished, so A and then abolished whatever, and abolished under it, you should say 1. Abolished 1. Okay, abolishing. Okay, abolishing. Then abolish. So last one is SH, right? So here you had a number one, and then it has I, N, G, and this one you add one if it is the first occurrence. So by searching this one, I know that to abolish, it should occur one, but if you go to the abolishing, it should be one as well. But second time abolishing happen, you actually will add this number to two.
Okay.
Okay, the data structure I described would be able to allow it because you see I already implement and try it already. Is
Right.
okay? Yeah.
Yep.
And eventually you should be able to go through every later. And how to go to every later? It's very simple. You let's assume that your dictionary is like this. You have A, right? And then B, and then C, and you have A, B. So you have a tree like this, and this one actually three times, this one actually two times, right? This one time, this one four times. So it goes through the tree, go to here, okay, you see this one actually three times. If it is a number, frequency number for this one. And then this one AA, okay, AA, you actually A three times, AA two times, B one time, C four times. That's what you traverse through the dictionary. You should be able to print that.
Okay.
Yeah. Is that okay?
Yep. Sounds good.
Okay. So roughly the template is give you a very small portion of the code. Okay. The template, of course, is a very small portion of code. You need to write the whole thing yourself. Okay. Try to write the whole thing yourself. The goal is to use it. Yeah, the goal is to use it like a dictionary. Okay, that's the purpose of having the try actually. Having a try is actually so try by itself is similar to a syntax tree. That's why we try it here. You know what I'm saying?
Mm-hmm.
Similar to a syntax tree. Do as much as you can. Okay, do as much as you can. As long as you submit, I usually don't give you zero. Okay, don't give you zero.
Okay.
Try your best. Yeah. And any other question?
Yeah. My final question actually now goes to the term project. So I know you were kind of,
Yeah.
I know you were kind of talking about it last week, but I just wanted to verify. So if I do something such as like a scheme language interpreter,
Yes.
how much of that, like, could I basically make like a calculation thing where I do like addition, subtraction, multiplication, division, and max min and all that?
That's okay. That's okay.
Okay.
We do not need you to put the whole language into there. Do as much as you can. Same thing. Key idea is that this one is an open project, so we do not limit you to say this you should include, this you should not, right?
Okay.
So you should try your best as put as much function as possible. But if you just design a program that just deal with plus and minus, I would say that's still okay.
Okay.
But I mean, when we look at the overall student, is say 30 students, we will know which one is better, which one is not as good, right?
Mm-hmm.
Yeah, in a way, we look at how much effort you put into the project.
Okay.
Yeah, but not every student can do a very decent or very complete project.
Gotcha.
So we do not expect you to write the whole Python interpreter. That's probably huge, right? But between Python interpreter and the simple just plus and minus function, I think there are still many different levels, right?
Mm-hmm.
You know what I'm saying? So up to you.
Okay.
Up to you.
Perfect.
We do not have a say that okay, your language can be as primitive as just a language of 10 words. That's one language. It can also be as complicated as 2 million words. Also, every single language. Well, what is the simplest language you can invent? It's a machine language, only 0 or 1, right?
Right.
Yeah. So even that is a language, right?
Yeah.
So only 0 or 1 is a binary language. You can use that to become a machine code for every machine, right? Depending on how you define it. Your simple set can be as simple as a 0, 1. That's already a language. So how you define a language and then implement that to make it work, that's actually the key. Okay, that's a key. So language is, there is no, well, key point in computer science is like define a language, right, and implement into a machine. That's the key that this course is trying to teach you.
Okay.
Okay, machine doesn't mean that you need to build a mechanical or electronic thing called machine. No, here we're talking about virtual machine, right? Java virtual machine is actually a piece of software. And what that machine mean to you in programming language, that's what we really want you to implement it. Language to machine. That's our goal, right?
Okay.
So it can be as small as a microcontroller for AC, right? For AC. Air conditioner, right? So air conditioner needs some control. Then how you design a programming language for it, right? Set temperature, update temperature, right? And then set the schedule, time when to turn on, when to turn off. If you design some language like that, that actually is okay. That means that you need to be plus, minus, and take square root. That's actually a lot of things you need to do, right? So think about if you design a language for a smart AC air conditioner, right? And how you draw diagram to make that work. So air conditioner, you may need to say, be able to manage the daily or weekly temperature control. Okay, so you may have a goal that, okay, target goal of the 24-hour by 7-day, your temperature should be set to what number. So you have a table like that, your target table like that, your schedule. Now, how you design a language to control your AC, right? And you should have a machine that's running that, okay, today is a Thursday, 10 p.m. My temperature setting at 75 degree F. Okay, and how you design a language that you can control that. So this one is your end executable plan, right? This one is your end executable plan. So this one actually is your binary code. In a way, it's actually your binary code, your executable code, right? Of course, you do not need to put it in binary. You can put it in text mode, right? But you need to have a final executable plan. But also there is a current time. So you think about it from here. Your hardware is this one. Okay, a 7-day, 24-hour temperature control plan, right? So you do not need to break it down into seconds. No need. Okay, just hour. Say hour. So you can control. Say right now Sunday, 10 a.m. and I want to control it to 75 degree F. Right, this is your target temperature control, and some of them may be off. Some of them on with same temperature, some of them off. So the whole table actually should be can be 24 by 7 by something. You know what I'm saying? That's your entry. So that's the target temperature you have. Okay, now I need to design a language so actually can put it. So basically, number one, you may have one instruction called clear. So clear, you set up the table to the default mode. So 24/7, everybody say set to 70 degrees F, right? So that's actually your clean condition, factory default, right? You can arbitrarily define that because you are the designer. So you say the whole table 24/7, everybody is on, okay, and then set to 70 degree F, or everybody is off. So whole table is off. For example, default mode, everybody is off. There's an instruction called clear, and clear will clear the table, right? Now you actually can have set. Okay, so for example, you can design the language set 75. Okay, you only use degree F. You don't allow Celsius, right? Celsius. You only suppose Fahrenheit, and then actually after that you should have a time one. Time one is like day, and then hour, and you know what I'm saying, AM PM. So remember that our project, actually our assignment number 1 is to convert the time format. You know what I'm saying? You should be able to set time, starting time and ending time, and then you should be able to mark the temperature for a certain region.
Okay.
You know what I'm saying?
Yeah.
Yeah, something like that. And then you, at this moment, your current time, okay, starting time right now maybe is a Sunday 0 a.m. So you should have a running machine, and then third, you may have a key, say start time. So you start to run, right? Start to run, something like that. Okay, and you may have stop or something. So this is a language you can define it by yourself.
Okay.
Okay, so right here, I'm giving you the idea of some language you can invent instead of just, hey, I always need to do a scheme language, or I always need to do Python, I always need to do Java. That actually is some sort of inside the box thinking. I'm encouraging to think about out of the box thinking. You know what I'm saying? Don't just think about, hey, programming language, I need to design a interpreter for basic language, or I need to design it for a Ruby language. No, not like that. Okay, you are allowed to think about out of the box.
Okay.
So something that is an AC control language is actually a very good example. Not too complicated, handleable, can be handled, but of practical use as well. You know what I'm saying?
Yep.
Yeah, and instruction set not too many, right? I do not need you to define a 300 instruction set. No, maybe 10, 15 keywords, good enough. Okay.
Okay.
And how you design it, you want to make it very simple. You want to do recursive descent. You want to use the Python, whatever we teach you in the class. It's up to you to choose the right tool set to implement it. You know what I'm saying?
Okay. Sounds good.
Yeah. Makes sense, right?
Yes.
And if you want to add what, detecting the error, okay, it's also very tricky. You can just actually just report error, redo it, okay, whatever. You can also try to analyze it with syntax and then reporting what kind of error you have. Up to you. We do not require you to say, oh, you must have the most decent debugger and also include an editor to it. Okay, that's up to you. If you have the extra time, it's okay. You know what I'm saying? You want to provide me an IDE for it, it's also welcome, right? I cannot say no, don't do that. It's extra work if you want to design a compiler plus IDE for me. Complete development environment for it. It's actually welcome, but not needed. Not needed for everybody. You know what I'm saying? And error message, you can be as primitive as just report there's an error. That's good enough. Then you try to follow your own language grammar, right? So up to you. Yeah, is that okay?
Yep.
But some language like this is a good example, AC control. Okay, now let's actually try to have another language that can be a candidate. say door lock, right? You actually will control the door. Okay, so you can have a number that can open the door, and you can reset the lock. You can actually detect who he is, ID control, right? So up to you, even as small as a door lock, you can provide a programming language that support it. You know what I'm saying?
Yes.
It doesn't mean that you have to be a real 100% programming language. So calculator is one example, door lock is one example, AC control is anything that control, anything that requires someone to do programming can have some language, some sort of language. That's the goal that we want to teach students to try in this course. Okay.
Okay.
So language in terms of in computer science, it actually is a human interface. Human interface to do programming. We call it a programming language. So you learn how to define a language, you put it on hardware, and also put it into the compiler. That this is the core idea of why we want you to have this the so-called programming language course. More advanced topic is like, okay, can you provide the programming languages to support AI, natural language processing, computer vision programming language, right? That actually more advanced. You know what I'm saying? That's more advanced. But we do not need you to do that. So language is a lot of the content you can explore.
Okay.
Does that make sense?
Yes, it makes sense.
Yeah. And the programming assignment 1 to 15, those assignment basics that training you different aspect of the programming. So you may see, hey, this course like has some assignment in data structure, some assignment in array, some assignment in map, some assignment in regular expression. What's the goal? The goal is that all the programming technique we kind of have some project on, and the overall goal is to support you to develop some sort of a final project that we will use these different techniques. You know what I'm saying?
Okay, that makes sense.
The whole goal is to design an interpreter, right? But I do not want to, hey, give you the project. If I really want to fix the topic, I can just work on the AC control language. Okay, and then I describe every aspect of the language. Then what? I'm designing the language, not you, right? You know what I'm saying? Then I'm the guy design the language, and you lose the opportunity to design a language by yourself from scratch, right? That's the purpose. Like why, you see, I can design the project 1, project 2. Why in final term project, it actually give you a blank check for you to fill in whatever you want to do. That's because like, I do not want to give you a fixed project like project 1 or project 2. Project 1 or project 2, we already define the domain, already give you some sample, already give you the goal, what I want you to achieve, right? But the term project is not. It's actually a very open project. You almost can do everything, but we still give you some very limited guideline that you need to design some interpreter for programming. That's it. But here I cannot give you every idea I can think of. I can list down the problem idea, maybe 20 of them, 30 of them. But that's my idea. I want you to explore yourself.
Okay.
What you can do with it. Not exploration is very important, because in the future, when you go to industry, can you come up with a project, then propose to your manager, and they give you the money, and you start to do it. That's a goal. You know what I'm saying? Yeah. That's a goal. That's a goal we won't like it. So So if I just tell you, okay, you go ahead and design this AC control programming language, then I'm limiting you into some sort of a domain, and you are working on only the engineering work. No, this one is not just only to do engineering work. I want you to work on some sort of pioneering work, not just engineering. Engineering, I give you, okay, spec. Number one, do this. Number two, do this. Number three, okay, let's do it. And you get 100 points. That's not the goal I want to have. The goal I want to have is that, can you do pioneering work? Define your own project spec and goal. Define your own language. Define of your own test case. Define of your presentation plan. That's some sort of hackathon, you know what I'm saying?
Okay.
Some sort of hackathon. Brainstorming, come up with idea, implement it, do fast prototyping, right? You know what's hackathon, right?
Yes.
What kind of prototyping for programming language you can come up with? That's the idea we want you to explore and try. And it doesn't mean that you need to give me like 1 million lines of a code, then that's the success. No, maybe 200 lines, maybe. That's acceptable, as long as you present a very clear idea of what you are going to do and make it related to programming language. That's it. That's all we need to learn. Is that okay?
Yeah, sounds great.
Yeah. But there are millions of languages you can do. AC controller, lock control, say backyard, the backyard watering system, right? Backyard watering system nowadays, if you use a very dumb controller, what do you have? You have the something like this. You have on and off, right? And then you program like every 5 minutes, 10 minutes, 20 minutes, you watering your backyard, right? And Monday off, Sunday off, whatever. So this one is also another scheduling program, right? Backyard watering system, you know what I'm saying?
Yeah.
So that's another example. You can design languages, so you can design language so that you can smartly control those things.
Okay.
Make sense?
Makes perfect sense. Thank you so much.
Okay. Other question?
That was all I had for this week.
Yeah, okay. And try your best. Okay, try your best. So usually you see I'm kind of flexible in the programming assignment. Okay. So as long as you come up with some solution, I will give you some grade. Usually I do not give you 0. Only if you miss something, you completely miss out a problem, then that may be a 0. You know what I'm saying? Otherwise, I do not usually give very low grade. I try not to do that. Okay, so try your best. Just try your best. See how you can come up with a good project. Okay.
Perfect. Thank you.
Yeah, but I finished all the video. Okay, I finished all the video. So a lot of video you should watch. Okay, and not only that, because in the video we also give you some simple code, and those simple code for some students can use them as a basis for you to develop something. You know what I'm saying? A lot of chapter we do have the simple code, and some of them are in the simple code. So I actually provide several versions of the lexical analyzer, parser, and also the event calculator, right? And virtual machine software. I actually provide several versions. All of them are something you should download and run. Try it. And they may be useful for you to build your own language. Okay?
Okay.
Yeah, so do not miss out that, okay? This course, I personally believe that I did a good job in terms of organizing the whole course and putting them into a course and combining different homework to it. Okay, compared to my previous version and existing course material by other people, I personally believe that the one I have is quite good. Especially, I try to narrow down to Python alone. Okay, some teachers do teach 10, 15 languages in the programming course, but eventually students learn very little. So here I try to minimize the number of languages just down to one. And this language, I want everybody to learn it well, including object-oriented programming, including functional programming, including using the language and tool to develop the interpreter, right? So this one by itself is a good course, well designed course. Just focus on language interpretation for using Python. Okay, we use that as the same topic. And the video you can watch, and then they are in-class demo code. All of them you can use them actually. Okay, welcome to use them. But of course, I want you to design a new project as new as possible. As try to implement your own language. That's the best. Okay, even though I have suggestions, but these are just for reference, not limited to these 3 topics. Okay. Any question about the video or material in this course or some other assignment so far?
No, that's all I had.
Yeah. Do you feel this is too tough or too easy or so far about the homework and everything?
Everything seems pretty manageable so far. Like I said, the only problem I really ran into was kind of project 2 so far. But other than that, everything seems pretty manageable.
Okay. And so basically, some of the material you haven't done it before, right?
Correct. Yeah, there's some stuff that's complete.
Okay.
Like specifically, I know one thing we had to do was like a scheme language thing for some of the assignments, and I was like, I've never used scheme language, so I definitely had to reference your video and then re-reference them a few times.
Yeah. So some of the homework, some people try to use Python for language. I actually deduct them by 10 points. Okay, and I encourage students to write purely in scheme. The purpose is that, okay, this also you learn in week A for the recursive call, right? Recursive call in Python, okay? So everybody should be okay to try recursive call. But in week 9, you are actually applying the recursive concept into the scheme language. And that is how you learn functional programming. Okay. So functional programming starting from where you are understanding about function, right? You're understanding about function. Then you need to be able to write a lot of recursive code. Then you can use a scheme language to write it recursive code. We follow the order to introduce it in that way, right? And scheme language actually is in practical use. Lisp, it is a dialect from Lisp language, and it offers some practical use actually. Yeah, there's some language using that. Okay, there's some language using that. Say you have the EDIF format. Okay, this one actually is actually used in the electronics, and they are in wait. This is what is sort of like Lisp, right? Right. The whole language is like it actually is a Lisp. Okay, it is a Lisp, and it is used in industry. It's used in electronics, so Daisy Design System, Mental Graphics, Motorola, National Semiconductor, Tetronic, whatever, UC Berkeley. They all they together invented this language. And nowadays still used in industry. Some companies still using that. Okay. Okay. And the goal is also this scheme language is the only thing that we introduce other than Python. But the goal is that your AC control language, your door lock language, your scheme language, everything, you should be able to define your own language, Then the next one, you need to implement it by Python, right? So you must be good in the domain language, you know what I'm saying?
Mhm.
If you want to implement, you must define the language well, and yourself is able to program in that language before you can design the interpreter to support it. You know what I'm saying? That's the purpose. We still have one extra language to learn. Okay.
Okay.
Does that make sense?
Yeah, that makes sense.
Yeah. Okay. Other question? No? Okay. And I'm converting this one to a 8-week format, start in March. Okay. Joseph, if no more question, can we stop here today?
Yeah, sounds
Look,
good. Thank
I
you so
don't
much.
think that there are more people to come today.
No, I don't think so, but I really do appreciate this. This helped me a lot. Thank you.
Yeah. Okay. Thank you. Bye now. Bye bye.
Bye.